Okay, here is the feedback for the supported choice exercise. The first question asks, with reference to an example, define the term external benefits. So we know that the reference to external means that this is going to have a third-party effect. This would be a group outside of the market mechanism. And we're also told that there's a benefit there, so that's quite straightforward. So that's going to have a positive effect. In a sense here, we now know that we have a positive externality is present. And so defining the term external benefits, a benefit to a third party, not involved in the economic transaction. In terms of examples, a number of good examples were given here. So we had things like vaccinations. So the consumption of a vaccination by one individual would create an external benefit in that somebody who hadn't paid for or received the vaccination would be able to get a third-party effect. They're not then at risk of catching an illness or a disease off of the first party who've paid for and received the vaccination. Other external benefits here we had in consumption, the decision by some people to ride their bicycles to work, and the third party benefit here being either the reduction in pollution or perhaps the reduction in congestion levels, allowing road users, car users, to be able to get to work or to complete their commute faster. So the key thing here, external benefits, the third party effect, the positive third party effect, the benefit to a third party, and then one relevant example. The second part of the question gives you a market for nursery school places, and we can see here that the marginal social benefit is greater than the marginal private benefit, and this is a typical diagram for when we have a positive externality. What we also see here is that the marginal social benefit curve is increasingly diverging from the marginal private benefit curve. And I want you to think, as you're going through this feedback exercise, I want you to think now why that might be and what does that tell us about the positive externality. The free market would look to consume where the marginal private benefit is equal to the marginal private cost. So that would occur at the equilibrium at T, and that would result in a market price of PE and a market output of QE. The social equilibrium occurs where the marginal social cost is equal to the marginal social benefit. That is at R. That'll be important for the third part of it, or for the follow-up part of this question. And that would entail a higher price of P1 and also a higher output. So if the market were to factor in all of the social benefit, then the socially optimal level of output would be Q1. So the next question we have is, well, which of the following measures could the government use to get us to the socially optimal consumption of nursery school places? So we're interested in trying to get the market to Q1. Now, how do we do that? Well, we need to create a free market equilibrium somewhere that coincides with the output level of Q1. If we look at the options below, a maximum price of OP1 per unit, well, the free market price is already below that, so setting the maximum price above that isn't going to have any effect on the market as it stands. The free market will continue to operate at P1, and the price ceiling, which is set above that, won't have any immediate effect. So we can eliminate answer A. A tax of VT, well, a tax is going to increase the cost of production for the firms, and what that is going to look like is an increase in the marginal private cost. And so what we'd end up with would be an inward shift in the marginal private cost curve to MPC1, and that would create a new free market equilibrium between MPC1 and MPB somewhere there, which would only result in not only a higher price than is currently prevailing in the market, but also a lower quantity, and that seems to be moving us further away. So we don't like that as a suggestion. A minimum price, let's get rid of some of those extra lines just so that we can focus in on what we want to do. A minimum price of OP1, well, again, that we might be able to get closer to the socially optimal price in doing that, but by raising the price from PE to P1, all that's going to do is move us up and along our demand curve, our marginal private benefit curve, and so we'd end up with a new output level, a new level of demand that would be further away from Q1 and would actually reduce the level of consumption, which again is not something that we're looking to do. So we're left with B, the idea of a subsidy of RS per unit. So that subsidy, in contrast to the tax, that's going to lower the costs of production. That's going to cause a fall in the marginal private cost. That subsidy, which is equal to RS, is going to bring about a shift, quite a substantial shift in the MPC. And that creates a new free market equilibrium between MPC1 and MPB at point S, and that coincides with the socially optimal consumption level of Q1. So the answer to part B of this question is B, a subsidy of RS per unit. The final part of this question asks us to annotate two areas on the diagram. The first is the area of welfare gain that would be achieved from this successful government intervention, and also what the socially optimal level of consumption or the quantity would be. Well, we've already covered one of those, so we know that the socially optimal level of consumption is at Q1. If we just clean the diagram up so that we can now see these areas clearly. So the socially optimal level of consumption we said would occur, the social equilibrium is at R, where MSB is equal to MSC, and so the socially optimal output level is Q1. In terms of the triangle of welfare gain, this is often quite a tricky area to discover. We're looking for the potential economic welfare that would exist on the units that were consumed from QE to Q1. And in the free market, those units are not consumed, and so we can't capture any economic welfare from them. If we were to successfully move the market from QE to Q1, the way to think about those units and why they're desirable is that for all of those units up to Q1, the marginal social benefit is greater than the marginal social cost. So, for example, the last unit consumed in the free market at QE, the marginal social benefit is the equivalent of a point V on the MSB, and the marginal social cost would be at point T. And so that vertical distance there is, in a sense, the net social benefit to society of that unit. That's true for all of the units from QE to Q1, that the marginal social benefit is greater than the marginal social cost. And so that area in there, that triangle there, is the area of welfare gain. So the area VRT. In question 2, we're presented with a scenario that I'm sure we're all familiar with, the all-you-can-eat buffet, and we're asked how the concept of diminishing marginal utility might apply in this instance. I had some really good explanations of the concept of diminishing marginal utility. The concept here really refers to it as our level of consumption increases, as we consume more units, the quantity of consumption increases, the extra utility that we gained begins to full. So for each extra plate of food that we consume from the all-you-can-eat buffet, each additional plate that we are consuming is delivering us less and less extra utility or additional satisfaction. What that does mean then is that the total utility is still increasing. Well, otherwise it'd be unlikely that we would continue to consume additional plates, but all that's happening is it's rising at a slower rate. And I had a couple of nice diagrams where people mapped out on the x-axis the quanta, or the number of plates consumed, on the y-axis the total utility, and showed that for the first plate, or the first couple of plates, utility rises quite quickly, but then as diminishing marginal utility starts to set in, we find that the total utility starts to increase at a much slower rate. It may even be that if we consume to excessive levels, we may find that our total utility, as we start to feel ill from that consumption, our total utility may well start to fall. That would suggest there's some irrational behaviour going on there. In B, the price of the buffet has fallen to £6.99, and this has resulted in an increase in total revenue for the restaurant. Well, if you remember from last year, this diagram was quite important. So we have our demand curve. We've currently got the price set at £8.99, and below that we can plot a total revenue curve. And we find here that for the reduction in price to £6.99, we can see total revenue increasing, is what the question has told us. And that must mean then that we're on the top section of our demand curve, and we know that the top section of the demand curve, the demand for the product is elastic, so answer C. What this means is that the reduction in price is bringing about a significant or greater than proportional response in quantity demanded, and so whilst each buffet dinner sold is generating less revenue, the fact that there are more units being sold overall makes up for that fact, and so total revenue will increase. And the final part of this question then, a regular consumer at the restaurant has seen an increase in their monthly salary of 5%, and they purchase the buffet offer 5 times a month rather than 4 times per month. What is the income elasticity of demand for buffet meals? In these sort of calculation questions, I would advise that you try to make clear the concept that you're working with. So we're asked for the income elasticity of demand, so I think it would be a good idea at this stage just to put the formula in that you're working with, and then we can plug the numbers in. We know that income has risen by 5%. The percentage change in quantity demanded, well, it's an increase of 1 buffet per month from an original consumption level of 4, so that's a 25% increase, and so the YD value comes out at 5. In question 3, we're presented with a total revenue curve that we should be familiar with, certainly from C block, and should be now been reminded of that from studying revenue in B block. The first multiple choice question caught quite a few people out. It can be deduced from the diagram that a lot of people opted for A here, that the firm would be making maximum profit at an output of OX. We have to remember here that revenue is not the same as profit. They are quite distinct, that in order to calculate our profit, we need to take our total revenue and minus our total cost. It may well be that at the output of OX, it could be that total costs are equal to total revenue. It could even be possible that total costs are greater than total revenue, so we wouldn't be maximising our profit. What we do see here is a total revenue curve where the gradient gradually decreases. We reach a turning point at X, and after that point, total revenue starts to fall. So on this side, to the left-hand side of point X, total revenue is increasing as output increases. So that tells us that our marginal revenue is positive, but because the gradient is decreasing, that also tells us that our marginal revenue is positive but falling. On this side, on the right-hand side of the total revenue curve, total revenue is now falling as output increases, That tells us then that our marginal revenue now is negative. Each extra unit, each addition to output sold is actually reducing the revenue that we receive. So our marginal revenue, the extra revenue generated from the sale of one extra unit, is negative. And we can also see that the gradient, the negative gradient of that slope is increasing. So what that tells us is that the marginal revenue curve, the marginal revenue curve is still falling, and that the negative value is only getting bigger and bigger as output increases. So that would mean then that if we were to plot our marginal revenue curve, it is positive up to an output level of X, but it's falling, and then it continues below the X-axis. So marginal revenue will be falling as output increases. Well, the only answer that fits that is answer B. That also says that average revenue will be falling. Now, we should also know that average revenue has got half of the gradient of the marginal revenue curve. So our average revenue curve will also be falling, but just not quite as quickly. In part B of this question, other than changing the price, outline 2 ways in which a firm can attempt to increase its revenue. I got some fairly basic answers here that didn't really put forward a specific or an exact policy. Talked about that the company could increase its consumer base without really explaining how it's going to do that. I also got some answers here that talked that again confused revenue and profit. So one solution put forward to increase a firm's revenue was to cut its costs, to reduce labour costs, outsource production. And whilst that might help to increase profit, that's not what the question is asking for here. So common ways, in a sense, if we're trying to increase the revenue, we would look to increase average revenue. So that would be an outward shift, an increase in the demand curve at an outward shift in demand. So at every price level, more units are being demanded. Things that we could do there, people talked about advertising. That also has the added benefit of potentially changing the elasticity of demand, making demand more inelastic, which does give the firm greater price setting ability, although again we're told we're not allowed to change price here. People talked about targeting consumer groups in new markets. So that was either looking at going global and looking to set up operations overseas, or maybe looking at new products as well. A final suggestion that I had that I thought was worthy of credit was that firms could look at pursuing mergers and so capturing the consumer base of another firm. And I thought that was a sensible way of trying to promote revenue. Again, that itself would likely come with quite a significant cost, so maybe in the short term the profits of that company would fall, with the hope that the additional revenue streams in the future would compensate for that with higher profits moving forward. And the final question of part 3, the diagram shows the supply, demand and marginal revenue curves for parking spaces in a local government car park. Now we're presented with a slightly different diagram, slightly odd diagram, in the sense that we've got a perfectly inelastic supply curve, which kind of makes sense, I suppose, for a car park, that there is a fixed amount of spaces available. And the question asks us, in order to maximise revenue, what price should the car park charge each user? A lot of people did end up getting the correct price, although their reasoning behind it wasn't entirely clear. In order to maximise total revenue, we would look to find the point where marginal revenue is equal to 0. At this point, the total revenue curve has reached its peak. Beyond that output level, marginal revenue would be negative, and so total revenue would start to fall. Equally, before that output level, marginal revenue is still positive, so selling further units, selling additional units, will make a positive contribution to total revenue, albeit relatively small, as you get closer and closer to the point where marginal revenue intersects the x-axis. So marginal revenue is equal to 0 when the output level is equal to Z. That corresponds with a point on the demand curve at H, but that's not the price. We need to draw a cross to the y-axis. So the price that we would set to maximise total revenue would be price K. And I think if we're going to show the economic theory behind the maximisation of revenue, we need to be making that quite clear, that marginal revenue needs to be set equal to zero, rather than trying to argue that some of the areas in the diagram are bigger than others. In terms of the certainty that revenue has been maximised at that price level, I think we need to refer to the revenue maximisation condition of MR is equal to zero. Okay, question 4. So now we move to some macroeconomic questions. We've got some figures here for GDP per capita for 3 countries, the UK, Spain and Italy. And we're also told that those GDP per capita figures are at purchasing power parity. Question A asks us to explain the concept of purchasing power parity and why it's an appropriate adjustment to make to GDP per capita figures. We must ensure that we actually deal with both parts of the question. And again, a few candidates failed to do this. The concept of purchasing power parity, we're looking here at the rate at which the currency of one country would need to be converted into that of another country's currency to buy the same amount of goods and services in those 2 countries. In effect, purchasing power parity is looking to take account of differences in the cost of living between 2 economies. So, for example, it may be that with the 3 countries we've got listed here, $1 or the equivalent of $1 in the UK may buy a certain basket of goods, but if $1 were converted into a euro in Spain or Italy, or converted into euros, it may be that the equivalent value of $1 in euros may buy a totally different basket of goods, or might be able to buy a bigger or smaller basket of goods based on differences in the cost of living. So purchasing power parity, what that does is it takes out differences in the cost of living, or accounts for that, so we get a more accurate figure. And that the value of doing that is that it allows us to make more accurate comparisons between GDP per capita figures to get a sense of the living standards between those, in this case, these 3 economies. Question B was done reasonably well. I don't think we had too many problems with this. The UK population was set at 64 million, and we need to work out what the total GDP is. Well, the GDP per capita is simply the GDP of a country over its population. Well, we've got that value in the table above for the UK, and now we've got the value there for population of 64 million, and multiplying those together we end up with answer A. In question C, the diagram shows the current macroeconomic equilibrium for this economy, and we're told that we have an appreciation in the value of the currency. Well, if we assume, just for this example, that the currency in question is the pound, the currency is appreciated, the price of the pound has gone up. Now, we need to be careful to think here about the impact that this might have on both sides of the ADAS diagram. On the aggregate demand side, an increase in the price of the pound means that the price of our imports will fall, and that will make imports more attractive, and so we'll see an increase in import expenditure. And the price of our exports now will be more expensive. It's more expensive for foreign buyers to buy our exports because the UK pound is now more expensive. It's appreciated in value, and that would mean that our exports would fall. So the overall impact on aggregate demand is negative, and that would mean then that the aggregate demand curve would shift inwards, and we need to make sure that we label our new aggregate demand curve and maybe even show the direction of travel. That was quite a common effect for people to identify. A lot of people left it there. What we also need to factor in is what the possible effect of an appreciation on the currency might be on aggregate supply. We've talked up here about the price of imports. What this would mean is that any imported, so our imports are now cheaper. So imported raw materials now cost less, and so the costs of production for firms will fall, and what that will mean is that we get an outward shift in aggregate supply as a result of a stronger currency. The final thing that you needed to do, because the question asked about what is the effect on the equilibrium price level and real output, it's not enough just to shift those curves. We also need to show what it does to the macroeconomic equilibrium, and this will vary in your diagrams depending on the size of those shifts, but there needs to be some attempt at least to show the change in the price level and the change in real output. Question 5, we have some claimant count figures for the UK from August 2014 up to February 2015. First question, calculate the percentage change in the claimant count over that time period. So in looking at the change, we first need to work out what the difference is between those two values. So the figure here and the figure here, that difference works out to be a fall in the number of claimants of 102,805 claimants. To calculate the percentage change, then we need to look at that change over the original value, and so that value of 102,805 divided by the original August figure of 961,149, and if we go through that calculation we end up with minus 10.7%. There needs to be some sense here that the percentage change is negative, so either an accurate calculation including the minus sign, or a statement here that the claimant count figure actually fell by 10.7%. The mark scheme is quite explicit on that for the second mark. Which one of the following options is most likely to cause a reduction in the claimant count? An increase in the weekly payment for claimants. Well, that's probably likely to make the claimant of JSA more attractive, it's more rewarding. Whether or not people are entitled to do that or not will depend on their different circumstances, but that's certainly not going to see a reduction in the claimant count numbers. A fall in employment levels would suggest that more people are then falling into unemployment, and again that's likely to lead to either to lead to an increase in the number of people who are trying or eligible for JSA, and therefore the claimant count figure would increase, so we don't like that one either. An increase in the size of the workforce was quite popular. We need to be careful to distinguish between the workforce and the employment figure in an economy. The workforce includes not only those people who are in employment, but also those people who are actively seeking work. So an increase in the size of the workforce may mean that the actual employment number remains constant, but we've just got more people who are currently unemployed but looking for work in the economy. If they're actively seeking work and their circumstances are appropriate, then it may be that they're entitled to claim JSA, so that might actually lead to an increase in the claimant count figure. A compulsory weekly interview for every claimant, that may well see a reduction in the claimant count, either because it will deter people, because there's an opportunity cost in terms of their time for attending that interview, or it may be that through that interview process the job centres are able to weed out people who haven't been actively seeking work, or maybe who are attempting to claim fraudulently. So a compulsory weekly interview for every claimant should go some way towards reducing the numbers registered through the claimant count. Two reasons why the claimant count may not be an accurate indicator of unemployment in an economy. I got some quite vague answers here. People saying, well, it may be that some people who are unemployed don't claim JSA. I think there needs to be a little bit more to it than just that. There needs to be some explanation as to why they don't claim, or maybe why they're not entitled to claim. They need to be able to show some insight into the claimant count and who is eligible for it. One good reason that people put forward as to why it may not be an accurate indicator of unemployment, people said that there are people who fraudulently claim JSA who are either actually in some form of employment but are able to defraud job centres and to claim JSA. So that would overestimate the figures of unemployment because those people actually be in work. Or it may not be an accurate indicator of unemployment. It may be people who claim job seekers allowance but who aren't actually making genuine efforts to seek employment in the economy, and therefore shouldn't be officially counted in the unemployment figure. Other reasons why people may not be entitled to the claimant count, it may be that they've actually they may live in a household with household income over a certain level, which means that they're not entitled. It may be that they've got adequate savings that again would mean that they weren't entitled to claim job seekers allowance. It may even be that they are currently unemployed. They may be currently seeking work and will be able to take on work in the near future, but there may be a social stigma that they attach to JSA and to claiming benefits that may deter them from doing that. So those might be some of the reasons that you could put forward, but I think there needs to be some sense as to why people aren't claiming, rather than just stating that they're simply not claiming JSA. In question 6, we're told that the UK's marginal propensity to consume is 0.5. This tells us then that for every extra pound earned in the UK economy, 50% or 50 pence of it goes towards additional consumption. So our MPC value is 0.5. We're also told that there has been an increase in expenditure. The Chancellor announced a £15 billion investment programme into UK road infrastructure. So that £15 billion, that spending that occurs, is an immediate increase to aggregate demand of 15 billion. But we're asked what the total increase is going to be in national income. So we need to factor in here the effect of the multiplier process. And if you recall from your C block notes, the multiplier is calculated by 1 over 1 minus the MPC value. So if we follow that through here, 1 over 1 minus 0.5, 1 over 0.5 gives us a multiplier value of 2, which means that the total change to aggregate demand or to national income, once we take into account the multiplier process, will be £30 billion. In B, which of the following is likely to reduce the marginal propensity to consume? We're looking here at factors that maybe would dampen consumers' animal spirits, and would mean that for each extra pound that they earn, less of that would go towards consumption purposes. Falling interest rates wouldn't do that. Falling interest rates would make it less attractive to save money, and so any additional income that was earned is less likely to be put towards savings because the return is lower and is more likely to go towards consumption. So the likelihood is of falling interest rates would probably have the opposite effect, would increase the marginal propensity to consume. An unexpected fall in unemployment, again, this should help to increase animal spirits, to improve consumer confidence. People are less concerned about losing their jobs if unemployment is falling in the economy, particularly if they weren't expecting it. And that would mean, again, that marginal propensity to consume would probably increase. A fall in average house prices. This relates to the concept of the wealth effect, a fall in the value of assets or a change in the value of assets. In this instance, houses being the asset. A fall in the average house price would lead homeowners to suffer from the negative wealth effect, and what effect that should have would be to reduce consumer confidence, reduce animal spirits, and it may then have a negative impact on the marginal propensity to consume. So the answer there is C. And the final question, the diagram asks us to illustrate the short run and the long run effects of the increased investment spending. Well, we've already said from the first question of this question, or the first part of this question, that the increase in national income, the change to either government expenditure, the investment in the economy, the extra round of spending, is going to boost aggregate demand. So we get an outward shift in the aggregate demand curve. But the long run effects of increased investment spending, it's also likely with improved infrastructure to raise the productive capacity of the economy. So we would see that there are some supply side effects of improved infrastructure, and in the longer term we might see an outward shift in aggregate supply as well. And again, just given what I said earlier about completing diagrams, we can show that for those shifts at least,